Research is a worldwide scientific community devoted not only to find new therapies and cures for specific disease, but also to improve the everyday life, and in particular the patient everyday life. This project is designed to provide the students with a comprehensive understanding of the pathology, in this case the Duchenne muscular dystrophies, plus the different therapeutic approaches, including the most relevant and up-to-date therapies available. Muscular dystrophy refers to an heterogeneous group of genetically related diseases. In particular, we focus our attention on the Duchenne muscular dystrophy. That is a really severe form. It affects patients really in the childhood between 2 and 5 years of age, and also the progression is really fast. Even the lifespan of the patient, unfortunately, it's really short. This pathology lead to muscle weakness, skeletal muscle structure instability, leading to the use of the wheelchair, and also the patients unfortunately develop severe cardiopulmonary diseases. Due to all these problems, there is no actually a cure for this kind of disease, and there are many different therapeutic approaches.
So an exoskeleton is, as the word says, an external skeleton, and it comes from the use that the animals do of the external skeleton. So they use it for protect their body and to help for the movement, for example, in the case of the crayfishing, for example. So we use this idea in a bio-inspired approach. We use this idea to have an external skeleton for people as well. So in an Iron Man-like idea, we use an external shell that helps to perform the movement for the people who cannot perform the movement by themselves. In this workshop, we want the students to go through the different steps of the development of an exoskeleton. Of course, we use a simplified version of an exoskeleton, and we want to assist only one joint, in our case the elbow. The first thing we need to do is to build the exoskeleton itself. So the first step is more a mechanical part, where we assemble the different parts, so the shell, the links, the other shell, to be able to effectively move the elbow in a smooth way. Then the second part is to program the exoskeleton to obtain the movement that we want. So in this case, there are two steps. The first step is to get the information from the patient of what he wants or she wants to do. And the second part is to move the motor that is integrated in the exoskeleton to obtain the desired movement. Where we use engineering skills and medical skills toward the development of a technology that might be really useful for our end user, so in our case, the patient.
I was very excited to take part of the Exo project because we finally had the chance to put hands-on the knowledge we learned during different Polytechnical courses. The Exo project was actually quite fun because the first part of it involved building the exoskeleton itself, which was kind of challenging because, of course, we studied circuits in class, but it was completely different from doing it yourself. Finally, the last thing we did was programming the exoskeleton. We studied programming with Python, but we had to apply a completely different syntax, which was Arduino. And so that was quite of a challenge, but it helped us realize, or at least it helped me realize, that once you study computer science and you understand how the algorithm works, you can apply to any kind of syntax, and that was very empowering.
This Exo project was a really valuable experience for our path, as it was one of the first time that we were able to experience our knowledge in a real setting. In fact, what I found is the most striking legacy that I take from this experience is the fact of being able to deal with problems that can take place in a real research setting. For example, we had to deal with problems related to the EMG sensors, but also to the algorithm and also to the anthropometrics of the subject that was using the Exo itself.
They are MEDTEC students, so they not only will be the medical doctor, but also the researcher of the future. So this is why it's really important for me to involve them since the beginning in research, showing not only the medical field, but also the state-of-the-art technologies available.